Actually, this word parametric design is a bit overused, I would say, because in history-based CAD, people understand one thing under this parametric design, and say Grasshopper users also call it parametric design, and we here in Bricsys, we use our own approach for parametric design to link parameters to the model. So, and let us remind you what is it. So, can we switch to the demo? Yes. In Bricsys, we implement parametric design concept using 3D constraints. So it is when you apply 3D constraints right to the faces of the 3D solid. Like, for example, here, this is a fully parametric flange model, which is controlled by 3D constraints. And main constraints are radius and distance constraints, which define the internal radius of a hole and the thickness of this flange. And as soon as you change the parameter, BricsCAD automatically rebuilds the model to get the desired configuration. And this is what Ilya is showing. Just using mechanical browser, you change parameter and the system automatically rebuilds the solids and the array of the solids. What is also interesting that inside there is, you can see standard parts. It's standard bolts which have predefined number of available lengths and sizes, and this is controlled by design tables. And this is an intermediate component which combines array of bolts and subtractor solids. But for each bolt, there is a design table which controls, which links the size of the bolt and the available number of lengths, which is listed here. And still, when user changes the parameter, the BricsCAD selects the proper configuration and adjusts the length, for example, when the size is changed. So this is basically what we call parametric design in BricsCAD: change parameter and regenerate the model. But in V20, we little bit turned it upside down. So we did a conceptual change that we're going to show you now, and it is we made the not parameters to drive the geometry, but opposite. We let geometry to drive the parameters, and we call it geometry-driven constraints, which means that when now using mechanical browser, you can change this. Yes, switch these two main constraints to geometry-driven state, which means that the user now, Ilya in this case, can easily modify the sizes of the hole just using direct modeling tools like push-pull or move, and the system will recompute the values of geometry-driven constraints. And what is interesting, these values can be used as the parameters of other parametric components, the bolts in this case. So, and still the design table is still in action. So if the changes in the geometry matches one of the configurations, you can see using our bill of material panel, which is also a new one and will be explained a bit later. You can see that still the sizes of the bolts, even after direct modifications, they are chosen from the design table. Well, this is one of the examples when geometry-driven constraints allow user to do some conceptual changes, so to easily manipulate the faces and see how other parametric components adapt for these manipulations. But this is more for conceptual design, to see, to catch the required shape of the model, to explore different variations. But let's switch to another case where geometry-driven constraints help not only with conceptual changes and design variations, but they help really catch the required parameters of the in more complex assemblies. Say, if there are in the assembly there is some distance which is not obvious to calculate and to use as a parameter of other parametric components, you can use geometry-driven constraints to catch this. This is a sample of the supporting column of the escalator model, and the main parameter here is the height of this model. And this purple, I would say links. Their lengths actually not known up front, but the height is known, and so it would be quite hard to write formulas and expressions which would define the length of these purple links. But here, how this model would behave if you just change height without using this new geometry-driven constraints. So we just the lengths are fixed, and it is you can see that the gaps appear if you just change the parameter. But we up front we created this link length constraints, and switching them to geometry-driven state, we can catch this distance between holes, between mounting holes, and use this distance as a parameter of the link constraints in the model. So now just yes, as you can see now, the link parameters are used here. The parameters of geometry-driven constraints is used as parameters of parametric components. Yes, and now if we change the height, then first the height will be updated, system calculates the required distance, and then the links are updated correctly. And of course this fully maintains the assembly structure of your model. For example, using the bill of material manager, you can see that the required lengths are used also, and still you have the two links of updated size. That is okay. But this is one of the features. I think it's a very conceptual thing that when you can make it opposite, to not drive the geometry by parameters, but first drive parameters by geometry and use these parameters wherever you want, for example, in arrays or in parametric components. That is, okay, let's move further. Actually, what we add in the V20 also, it's another sort of parametric behavior. But yeah, let's switch to, yes, our escalator assembly. Yes, that is. Actually, previously we were more talking about controlling the dimensions or sizes of the model using 3D constraints. But we can also, with V20, we also introducing a semantical thing, which semantical parametric entity or feature. We call it suppress feature, which allows to control presence of an object in the assembly depending on the values of parameters. Yes, this is a new feature which we are introducing now, and this feature allows to identify a group of entities which presence will be controlled by a parameter for which you can use an expression. Actually, Dmitry already showed this morning. Ilya now added this supporting column to the suppress feature, and by default it automatically disappears, but you can control the presence of this supporting column by parameter and use some expression. So if you type, if you type here an expression which is a sign of the difference between some fixed height of 7 meters and the current height of escalator, then we can control the presence of this supporting column depending on the height of the model. So, and of course this is also taken into account when you, say, build the bill of material table. So here you can see that in the bill of material table the column is absent, but if you switch the height to another value which is greater than 7 meters, then the column automatically appears and the bill of materials also updated. Let's see how it happened. Yes. This is what we call top level bill of material, which enumerates only the top level components of the part. So you see that the steel component is updated. Generally, steel component appeared in the list. Theoretically, you can do the same things with frozen layers, for example, just hide and show geometry by putting it on a frozen layer on back, or by freezing particular layer and turning it off. But in this case, it won't be taken into account, for example, when bill of material is generated. So this suppress feature is has not only visibility behavior, but also behavior with respect to bill of material. And not only, let's return to the link model, the flange. Yes, and for example, what we can do if you just hide the bolt subassembly here. Yes. So now bolts are hidden, and you see that the openings or holes are still here. But if you put these bolts really into suppress group, the holes will be healed. So it's another, I would say, difference between frozen layers and suppress feature. If you select the holes and create suppress feature, you can see how it will happen. That's what we wanted to show. So it's difference between, but also now using suppress group, we can control the presence or absence of a particular set of entities using expressions. Well, but this is not only another thing we are gonna speak now is about new sort of parametric constraints that we are introducing. As you already heard, that we are extending animation capabilities with BricsCAD, and we will talk about it a bit later. My colleagues will explain you about new animation framework. And to support this from the side of the 3D constraints, we introducing what we call path constraint. This is quite a simple thing which allows to attach a point to a curve and specify the parameter at which this point is coincident to this to a curve, and not only specify this parameter, but also you can change it and see how for example, in this case, the point can be moved along the curve. That's to create this constraint. It's quite easy. You select the point, select curve, and press new button, create path constraint. This is a basic example, but as this general constraint, you can combine it with all others. It's not very interesting to see how a single point is moved along the spline, but also you can add additional objects to it and see how this parameter drives your more complex models. And as this parameter is, as this new path constraint is parametric, you can use the parameter of this constraint in expressions. And for example, here you can use an additional angle constraint. You can control the angle of rotation of these two wheels while the parameter is changed. This is, well, a bit maybe artificial, but a funny sample how this new constraint can be used to create animations. But let's switch to something more real. For example, we can imagine that we need to simulate how the process of cutting a hole in a pipe can be modeled. Can happen. So we need a sort of animation or simulation, kinematic simulation of this process. And here we also can extract an edge, which in this case is intersection of two pipes. This spline edge is extracted and the path constraint is created. In this case, Ilya, if you can show the second pipe, which is hidden. Yes. Yeah, this is actually what we'd like to model, the connection between these two pipes. And in this case, the direction of the robot, of the instrument, the tool, is parallel to this second pipe. This is also achieved by using 3D constraints of parallelity between the tool and the second pipe, but using different combinations of 3D constraints, it's quite simple to get another sort of movement. For example, here we can enable the parallel constraint between the between of the tool one of the planes of the tool and the XY plane of the global coordinate system. So in this case, the tool is moved always vertical. And what is more realistic, this is a bit more sophisticated combination. We now disable this parallel constraint, and there is distance and perpendicularity constraint between axes. So in this case, the movement, the idea is to get a movement when the tool is always perpendicular to the bigger pipe. So which simulates the movement of the real tool when the tool is always directed to an axis of a bigger pipe, using the same geometry-driven constraints that you could apply to the parts of the robot. You can extract the values of parameters and use them as a driving parameters for you. Now inviting Christian to continue our part and show you our new amazing sheet metal features. Thank you.
Okay. Okay, this year we have, you have seen the demo this morning, we have developed a lot about sheet metal, but I will just show you the main new features. First, we have had this feature, M and teardrop. This is very popular in sheet metal. It's avoid sharp edges, and not only, but mainly for avoiding sharp edges. You will see as it works. Now, tabs and slots. It's to guarantee the positioning between two parts. So you will see that we have made something which is editable and very easy to use. Third, we have used the propagate function, which is existing elsewhere in BricsCAD, and we have applied for several things, and I will show you how to apply with the split function, and you will see it is very comfortable. Now, this is also a very nice function. We can draw a contour anywhere in the space, and just clicking an existing flange, you get automatically the bends between the contour is transformed in a flange, and the bends is creating automatically. It's very fast. Then we have also improved the drawing. Now it's very easy to put together the view, front view, top view, etc., isometric, and the unfolding view in the same document. It's very useful for people in charge of fabricating. That's all, folks. For this. So now, let's do the demo. First, hem. We will make a zoom on a corner, and you will see there is three main way to create a hem. It's what we call closed hem, so it's scratched. Then teardrop. This is, of course, different. And open hem, there is a gap between the two flanges. We will use the teardrop for this on this, and you will see that we can make it full or partial. Then we will, and on this corner, you can follow or not the geometry. So we will accept this. It's our first. Then we will create a basic open here. Just Ilya shows that we can edit. For example, the length, the gap. The length is 35. You can edit for okay, and the gap is 2. It can be more. Then what happens if we select 3 edges with a special geometry? You see that it's very nice because there is no collision at all. In the corner on the top there is a meter, and in the corner on the on the bottom the hem follow the bend lines. So there is no collision, and you can unfold without any additional job. And then you have a special annotation, which is M, the gap, and the plus or minus, which indicate if the bend is down or up. This is what we call hem and teardrop. So now, no, yes, the part on the bottom, we have seen this part this morning. The part on the bottom is unfoldable, but it's difficult to produce because there is no space enough to put a tool. And we can, of course, make a special tool, but it's not evident. So we will separate. We will separate this, create a junction here and here. But the problem that we cannot guarantee, one more time, yes, but we cannot guarantee the positioning of those parts. So we will create that we call tab and slot. So first, manually you can manage the position and the length of this tab. So we can do one and okay, one tab here, and another where you want. So you can create 1, 2, 3 at the position you want. This is a manual way. Now there's on the other side, I will show you something a little bit more automatic. This is the array. So we will create a array. By default, there are those values, but this is editable. So for example, there is 3 tabs. We can change for 5, for example, and then change the distance in order to make something symmetrical and correct. So 100, yes. Okay? And then the length of the tab also. Every parameters are editable, and so you got something correct. Okay, it's very easy, and very easy to manage because everything is editable. Then I don't show, but you can manage also the gap between the one part and the other. You can put fillet or chamfer to the tab to help the positioning, etc., etc. So let's go to this. This is the step of the escalator. We decide to reinforce this part, and so we will first reduce the length of this flange, just in moving surfaces. This is so we reduce the value. Then we will create a profile. In this case, it's a simple rectangle, but it can be any kind of profile. And we are sure that this profile is on the main part. And then clicking on this profile and the part, we create automatically a flange. Then we can, of course, create some additional chamfer holes and so on. And in copying the hole, we create a new hole, and then we will unfold. Collision. Problem. I would say it's not a problem. Just we will use the associative unfolding, and then just pushing a little this face, we will remove the collision, and the part is producible. Then we will use this part to show you the way to create easily a document. First, we will put the two views plus the isometric view, and then we will use the unfolding and put it directly on the document with the same scale. So it's very easy, and the guy in charge of fabricating has everything needed. I think this is the last sequence. Now, let me introduce Egor Ermolin, who is my partner in crime for sheet metal, and he will give you some tricks, and listen to him.
Okay, thank you, Christian. And as Christian told, I'm Igor Ermolin, and today I will tell you about some expert cases of sheet metal applications we studied together with users. And moreover, I see some users in the audience. And we were so excited by these cases that feel that now it's time to share them with you. And that is why our story today will be called A Fistful of Tips You Should Know About BricsCAD Sheet Metal. And we will tell about some features which we deliver in V20 and in some previous versions of BricsCAD. The first one probably is the most complex. It's a tricky mechanism which connects settings, mechanical browser, and commands. And so what we have, in settings there is a sheet metal section, and two groups have the interest. The first one is commands, which customizes behavior of sheet metal commands, and second, initial parameters, which initializes sheet metal context. It is the content of mechanical browser. And we decided that all the settings are stored in the drawing. And this graph shows the dependencies. So here for operations we mean both commands and operations which you can do by right-clicking menu in mechanical browser. And a thing to know and to understand that changing setting doesn't immediately affect on the model, but only through the separations or when you create a new document. And that is why we give advice that once you have determined some default settings for your process, you should create drawing template with them, and you will start your sheet metal design with this template. And next, an evident thing is that sheet metal by default preserves external dimensions of the part. And for example, when you create the model from scratch or edit it, it is usually designed that way that it doesn't exceed external hull, but expands inside. And the decision where to extrude each part bases only on analysis of input geometry, and so far we don't interact with the rest of parts in assembly. And for example, the part we created here, it was created by extrusion from contour. It is thickened inside by polyline, avoiding possible collisions with nearby geometry around. But as Kristen emphasized, you are not a prisoner of this approach, and if the default one doesn't suit you, you always have a possibility to locally flip the flange or change entire model. So on this video, we extrude the polyline to sheet metal part, and you see it stays in between the rest of assembly, and moreover, this behavior is kept when we change the thickness. So this is the default behavior, and this polyline is a bit different. And if we extrude with default behavior, we have the collision. This is not what we want. That is why we locally flip only a single flange. And it is shifted by thickness, and moreover, it behaves differently when we flip the thickness of the part. So the summary for this slide is that there is a default behavior which allows you to model the part inside, but you always have a possibility to switch to another behavior. Next is assemble parameterize. So this can be considered as a specialization of parameterize command, which takes into account implicit constraints which come from the fact that part is sheet metal. And if we neglect these constraints and run a regular parameterize, we will get over-defined model. This is not what we want. And that is why when we say assemble parameterize, we mean recognition of design intent, taking into account that part is sheet metal. We have intellectual approach to arrays, and also the result part can be naturally integrated as a part in context of assembly design. So here we will call assemble parameterize on the sheet metal part, and it will create constraints, parameters, and recognize array. So these red slots are for the array. Now let's see what happens if we change the value of the parameter. On moderate change, just the gap between array elements is increased, but if there is sufficient space, a new slot will be appeared. Next, we switch the parameter to the geometry driven, and we'll do some direct modeling operation like push-pull. And as you see, due to the nature of this parameter, the array adapted and extra slots appeared. And that is why we believe that with results of assemble parameterize, you get highly intellectual model which you can modify in different ways, and all the cases will bring you to valid results. And form features. So when we design form features in BricsCAD, we considered that there will be a library of standard form features with possibility to expand them with custom one. And for technology, we chose mechanical components and beam insert as a way to insert the features. But as we found out, sometimes users use them differently. They use them to propagate some assembly data and annotations on 2D DXF part, which we obtain by unfolding. Here is a blank solid, and we will insert a custom feature which we not go to produce by forming. So instead we rather cut some hole and make welding. But we want to propagate this information to DXF. This is preview. And this is the result DXF file. So the tip is that unless your geometry will be produced by foreman, you can use this mechanism in order to propagate your annotations on the DXF. Next, lofted bands. So they found very good application for tube design, and in next video we will check scenario of getting precise unfolding of complex case using only sheet metal commands. So first of all we will recognize sheet metal, and then go junction and create in order to cut one of the tubes. And this geometry is rather complex, so this operation takes a few seconds. It's finished, and now we can move out the tube out of welding, and before unfolding we should split it at the proper place. For example, yes, we do splitting here, and in order to get precise dimensions we increase number of subdivisions, so right now it is important. And you see we unfold tube as a lofted band, and what we get precise dimensions and smooth border transition. So in given case we don't need bend lines, annotations, we remove them and keep only the solid. And if we roll back the solid, we will get initial tube. So we are constantly considering scenarios when the user can minimize his mouse clicks and number of command calls. And we started from considering multiple input for the commands when typically you can select several edges or even entire part for operation. And in V20 we expand idea more, and in next video you will see how system make offers where operation can be applied. So this is a bend commute model from our previous presentations, and we will select only the single edge and get the proposition for the flange edge operation. So we accept everything, enter the values, and get the result. So before it would require us to select all the edges. And same we do for splitting. We select a single vertex and got a rather reasonable proposition where a split also can be set, and also there are configurations if they are possible. So we do the split, and again we made only one selection and only single command call. And now we can continue our scenario. Here we disable features in order to prevent constraining which comes from junction. So disable features allow us to detach the parts. And for example, do the unfolding. Next, let's speak a bit about that funny balloon which you possibly already saw. So we called it report panel. And in sheet metal it's widely used, and this modern tool provides very precise information where the failure happened. And the only report panel mode setting controls its behavior. Here we have a poor sheet metal part which fails to unfold. But fortunately, report panel shows us where the problem is. And if we click on the links, we have the geometry highlighted. And now, when we know where the problem is, we can recover it using, for example, sheet metal commands or some direct modeling operations. Also, there is an option more details. So, yes, let's go to it. And then we switch to tree-like view, where the same errors reported. And it is called more details because, in case, for example, some DM audit results, report panel will have even more information that a balloon has. A Kfactor. So first of all, let's recall what Kfactor is. So this is a scalar value which defines the position of natural surface for the bend. And it is Kfactor and bend tables which deliver you precise dimension and shape in unfolding. But in BricsCAD Kfactor is also used in modeling commands. So for example, before some unfold can make a perfect circle on the place of corner relief, a relief create tool has already been aware of a proper Kfactor. So we are going to work with bend tables for this model, and bend table contains bend deduction. This is what you can measure on a physical part. And as you see, it is CSV file. So we load it, and we load it before we make operations. Next, we'll switch a corner relief to a circular type. and this one. And implicitly for us, bend table will be taken into account right now. In order to prove that we can unfold, and you see it's interaction of all the comments and the bend table, that is why right now we get a perfect circle here. And it can be important because making circular corner reliefs is usually cheaper. So we have 3 advices. That for precise results, you should make your own bend tables, and bend table will operate with bend deduction. Second is that you're better to load bend table before you start modeling. And third is the best place for bend tables is a drawing template file, where you put it only once, and then you start your modeling from this template file. And now let's speak shortly about 2D output. For sheet metal, it is unfolding. And with V20 you have several options. So you can have a regular semi-unfold command, you have associative unfolding for precise direct modeling, editing and avoiding collisions, and there is a new feature which is unfolded views as it is shown on the picture. And now you can easily put your unfolding on paper space. Next, you can customize your unfolding. The most easy is just to adjust layer properties in settings. But next, some requests can be covered by Lisp script, as it is shown on slide. It's a real case coming from Australia. And where we edit up and down annotations to the bend lines. And let's also mention Xdata as a perspective right now, which will allow us to put even more annotations for bend entities, which later can be recovered by your script. And finally, let's mention more automation possibilities. So for some smaller conic scenarios, there is a Lisp API, and Brics Sheet Metal API gives you the power to implement or customize your own sheet metal application on the top of BricsCAD. So literally, you can implement your second sheet metal. And if you want to be more simple, but still in automated context, you can continue with assembly expert, which does batch processing. And noticeable enhancement of this command is that now delivers easy to parse JSON output, which is very detailed. And so your automation scenario can run assembly expert and then interpret JSON after it. So these were just few features of BricsCAD Sheet Metal, and we motivate you to continue exploring BricsCAD, revealing new features and APIs you can use to boost your workflows. Thank you for your attention, and I will invite Maxim Shalovsky to continue.
Okay, thank you, Igor. Couple of seconds to start my presentation. Surprisingly, there is. My name is really Maxim Shalovsky. Good news that you don't have to pronounce it. I just did it for you. And I'm a team leader in BricsCAD, Bricsys, sorry. My team is in charge of some features that probably not as spectacular as my colleague just shown to you, but still important. Because, as you've seen, my colleagues demonstrated how to create very complex geometry in just a few clicks because of our powerful tools. But in the end, when you get this geometry, you still have a question how to manage it. Because, as you know, it just starts with creation of geometry. Let me explain what I mean. Well, and by the way, this is the name of my presentation about tools that allows you to train your assembly. Okay, let me explain. This is a typical assembly you may deal with. And it doesn't look like very complex from outside, but believe me, it's very complex because it has more than 3,900 parts, about 4,000. It has more than 200 types of parts, most of them are non-standard. And in the deepest place, it's 8 levels from top to the bottom in the assembly tree. So it's really quite complex. And when you work with it, you may have this question. It's quite large. How should I manage it? And by manage it, I mean how to navigate it, how to adapt it to your customer's needs, how to create proper documentation, including schedules and drawings. And last but not least, how to create a proper presentation to your clients. Because as we know, presentation sometimes really matters. And another good news for you, BricsCAD Mechanical has just the right tools for that. And let's start with Mechanical Browser. It's a simple but very convenient tool to navigate your assembly because you have all your product structure up to the second part, up to the last part, sorry. You have all constraints, all parameters, all features, all special use such as exploded view in one panel. And moreover, you can select any item in this panel and see its properties and edit it if you need to change them. And in BricsCAD V20, we added a new feature which allows you to manipulate many objects simultaneously. So now you can select many objects, not just one, and see their common properties and change it in one click. It's a simple change, but sometimes it makes all the difference. Another important thing when you work with assembly is bill of materials. And those of you who previously worked with BricsCAD Mechanical probably remember it like just a plain old table inside your drawing, which shows the list of all components, but that's all. In BricsCAD V20, we completely changed it. Now it's based on data extractor technology, so now you can extract any possible properties you have for your component. Moreover, we added more tools to configure your panel, your bill of materials, because now you can add footer rows for each individual column. You can adjust sorting, you can adjust units, how to display them and how to represent them in a table. You can adjust filtering, what entities should be in your table and what not. And you can also add your custom formula fields. And of course, you can save it and reuse it as a template in your future assemblies. And moreover, it's not only a command. It's not a command line tool anymore. Now we introduced a new panel that you probably noticed from presentations from my colleagues. And this tool allows you to configure and edit any of your bill of materials, including existing one, in very user-friendly, intuitive, what you see is what you get manner. Exploded views is very useful when you create documentation for your assemblies because it allows to see what's inside and how to properly assemble or disassemble it. In BricsCAD V19, we started to implement our toolset to create exploded views. So we added a possibility to create semi-automatic exploded views with one direction. In BricsCAD V20, we extended it even more. So now we have fully automatic exploded views that you probably noticed this morning. And also we added fully automatic trailing lines. So you can see the relationship between parts not only in animation, but on static pictures and drawings as well. And you don't need to just apply it for entire model. You can combine manual and automatic exploded views in one single drawing to get what you really need. And of course, it's fully supported in drawing views. Speaking on which, BricsCAD has very powerful tool set to create both standard and special uses, such as exploded views and unfolded views. Of course, you can create section views, you can create detailed views. Now we have fast or draft quality mode and high quality mode, so you can choose between getting precise result or getting result quickly. And also, as Dmitry already mentioned, we now support display of threaded parts, such as bolts, rods, nuts, holes, up to the drawing standards. So with this tool set, you don't have to make these drawings by hand. You just need to see the result and adjust it as you need. And if you need something more than just static images, now we have animation editor. It's more powerful than it was in BricsCAD V19 because now you can animate many parameters at once. That's right, it's parametric. And it means that in BricsCAD you can animate anything you can parameterize. It gives great flexibility and it gives great power. But you don't have to have a PhD in BricsCAD to reuse it because this panel has very intuitive timeline-based interface, sort of like standard for video editor, and you can use it you can get used to it in a few seconds, I guess, and you can write very complex drawing. Believe me that this video that you saw this morning, this escalator video, was completely created using this panel with no additional tools to edit it. So, as you can see, BricsCAD has tools to navigate, to modify, to create drawings, to create specifications, and to present those assemblies to your clients with very impressive animation. But of course, you don't have to believe me on my word, because we now have live demo, and my colleague Ilya Tatarenko will demonstrate with very little help from my side how to work with those features. And let's start with Mechanical Browser, because it's very useful when you work with such huge assembly like this. As you can see, it has all structure, all detailed structure for this part, and you can see how many parts it is inside. And of course, when you select it in the browser, it will be automatically highlighted in the model. And again, if you select it on the model, it will be automatically selected in the Mechanical Browser as well. So now, if you select, say, side panels, like this, Mechanical Browser automatically selects corresponding items. And now you can see common properties of those parts. And for example, if I want to change visual style for these components, I can do it now with one click by selecting the appropriate visual style, say X-ray in this case. But of course, it could be done before by using like a context menu or properties panel. With BricsCAD V20, you can do much more than that. For example, you can change parameters of many form features at once, or any other sheet metal features. And let us demonstrate it using a part called Handrail Guard. It's at the bottom of this escalator. And to find it, we will use a search field of this Mechanical Browser, so you can quickly find and open it. So now it's open, and you see there's 4 louvers in this model. And imagine you have to change the size to be like bigger for better ventilation. Before you had to do it manually, one by one, but now you can select all of them and just change the expression. Okay, and now it's bigger. So, as you can see, with BricsCAD V20, you can do more with less. Okay, but it was a Mechanical Browser. Now something more important for documentation. This is bill of material, and we will use this model as a pressure vessel model to demonstrate this new feature. Okay, so now we will open a new bill of materials panel. It's already opened on Ilya laptops, but if it's not, you can select it from a list of all available panel, or you can use a corresponding command. And now Ilya already added a bill of material. It's very simple, top level one. And of course, we can add something like footer to see the number of parts. It's done very easily just by selecting a proper tool. But of course, it's quite plain, right? Let's do something more interesting. This is a pressure vessel model. So in this part, we have something called nozzles. And sometimes it's very interesting to see all nozzles with their parameters in one table. It's called nozzle schedule. So now we will create this nozzle schedule by using filtering capabilities of our bill of material. Beforehand, we added a special word, in this case nozzle, to the description of each component. So now we can use it to filter our parts. And it's done. And we see that it's exactly 4 nozzles in this model. Okay, so now we can add this table to, say, paper layout, and to see and to like send it to our contractor for creating those nozzles. Okay, another interesting schedule or table could be a table of standard parts, because as you know, it's very important for like to buy enough standard parts for this part. And we will add this table using another feature. We created a template for it beforehand, and now Ilya opens this file. It's a simple text file, so you can edit it in any text editor. It's based on data extraction definition format, but of course it's extended because bill of material has its own specific. So you can obviously you can create it and edit it by using text editor, but actually you don't need to do it because bill of material panel will handle it for you. Okay, so now we added this template, and as you can see, it already has all necessary columns, so we can place it to layout. Okay, now it's here. But what if we need some changes? What if our manager just wanted to see the mass of each individual part? It's a problem. Table is already here. Okay, actually it's not a problem with BricsCAD V20 because now we can add a column to any existing bill of materials table. So now Ilya just selects the mass column from all big list of possible properties, and he adds it, and it automatically will appear in the table in the drawing, as you can see. And also, please note that BricsCAD automatically deduced the best unit for all values and placed it in the title. But of course, now we have a small problem because we have big parts with weight of more than kilograms and some grams. So possible we may ask BricsCAD to pick the best value for each individual column. Oh, it's already done. And of course, we cannot place it in a title anymore, so BricsCAD automatically added an additional column. But of course, to save space, you can ask it to place this unit in the same cell, like this. OK, but this is not all, because as you know, some kind of standard parts are bought by weight, because you don't buy like one nut or one bolt, you buy by kilograms. So it's interesting to know how much of each individual part we have in total. And to add this information, we will use a formula field. So now we'll add this simple formula. It's mass multiplied by quantity. But of course, you can refer to any other column in this table by using this quotation mark. OK, so now we can add it to our bill of material. It seems it needs another try. OK, so now we add it. And of course, we have to change its name to a more appropriate one, something like total mass of per item. OK, and we also can add appropriate unit for this formula field. And BricsCAD automatically uses the unit of a document or the user-specified unit in this case. And of course, you can adjust the width of the column to make this table more compact. So now it's more or less ready, and we can save this table as a template to use it in the future. OK, now let's move to exploded views. And we will demonstrate it on this model. Previously, this morning, you saw how to create fully automatic exploded view. Now we will show how to do a bit more complex than that. Basically, how to combine manual and automatic exploded view. And let's start with creating a manual exploded view, bottom level, because we want to be able to manipulate up to a single part. Oh, there's a problem in the report panel. It says that some component has a solid, which is not a part. It's a big problem, because exploded view in BricsCAD operates by parts, not by solids. So if you have a solid, which is not a part, exploded view will ignore it. It cannot work with it. But in this case, it's very easy to fix, because we will open this subcomponent. And as you can see, this axis is actually solid, so we need to add it to this big electric motor assembly. But there's another problem, because electric motor is a standard part, but it's a very complex part. It consists of several internal parts, and you don't want to see it in your exploded view, because it's standard. So what should we do? Well, we have a bill of material status, which allows BricsCAD to know how it should treat this part. And if you switch it to terminal, it means that the BricsCAD will treat this subassembly as a single part, both in bill of materials and in exploded view. So now we can save it and update the, of course, we need to update original assembly. And now we can try to create our exploded view again. OK, now it's ready, no warning. So very good. And let's start with this basement. As you can see, it consists of several parts, so automatic exploded view would try to move them separately. But if it's not what you want, you can just select it and move manually. Something like this, yes. And now you can add an additional step to our exploded view, so it will be correctly registered as a part of our disassembling or assembling process. And as you can see, BricsCAD automatically found our modifications and save it as additional step. So now we can try to disassemble this electric pump. And of course, you can do it manually by moving parts to separate directions. It takes time, of course, it's possible. But why would you do it if you have automatic exploded view tool? And to do it, we will call explode move tool. And now it has a new mode called automatic. So now Ilya select this mode and select the parts he would like to explode. And in a few seconds, it's done. And of course, you can see the animation of this exploded view. So as you can see, you are not a prisoner of our automatic algorithm. You can make your alteration to get the best possible view you want. And of course, you just saw animation, so it's easily to understand how the part should move. But if you want to put it on a drawing, you should add some kind of trailing lines to represent the relationship. And to do it, Ilya will launch a new tool called trailing lines. And of course, it can work with both automatic mode or manual mode. For example, you can select just a few parts, and it will add trailing lines just for them. But now, in this case, we added its frontier model. And as you can see, all necessary trailing lines are placed, even for a part that we moved manually. So you don't have to use automatic mode to get the full potential of trailing lines. It will work for any exploded view, even created completely from scratch by hand. And of course, after that, you can place it to your drawing. You can send it to your contractors. Yeah, basically, you have already seen it this morning, so I would not focus on that much. Let's switch to something even more impressive. Can you believe it? We have more impressive and automatic exploded view. Okay, and this is this elevator. Of course, it's not the elevator itself, it's what we demonstrate using it. But let's start with the fact that this model is fully parametric. For example, it has a parameter to change the door from closed to open, like this, and back. And you can ask the elevator or lift to move upwards or downwards by changing corresponding parameter. Our elevator is a bit heavy, so it takes time for it to go upward, but eventually it will go. And of course, we can ask it to return back. Okay, so basically we have everything to demonstrate our animation. Expect maybe some volunteers. Anyone would like to take part? Maybe anyone? Oh, I guess we have 2 volunteers here. And of course, they also parametric, so we may ask them to move a bit closer to our lift or a bit further from it, as Ilya will demonstrate now. Huh? And now we can create our animation. And to do that, you should open the special panel. It's called Animation Editor. We have a convenient button on our ribbon. And basically, it's a timeline-based animation editor. So you can adjust the duration of a scene. For example, we can ask it to be 20 seconds. You can add parameters, you can add camera movements, and you can do it individually. So let's start with opening the door, because of course you cannot enter the elevator if the door is closed. And to do it, we add corresponding parameter, and we will add something called animation sequence, which defines the exact start and exact end, and the start and end value for this parameter. And being a parametric animation, it's very important to set the appropriate start and end values. Okay, so now you can check by moving cursor if the animation works as intended. Of course, you can play it back, but for our purposes, it's sufficient to just check few intermediate frames. And now we can ask people to enter by adding corresponding parameters and repeating the procedure. And of course, you can set the precise value for start and end, or you can just move it on a timeline by using your mouse. If, for example, you don't need a precise timing, you just want to have something like a sketch. Okay, so now we can check that our people really can enter the elevator. Now we should close the door, because really it's not safe to move up with closed doors, with open doors, right? So we need to add another sequence for door parameter. And previously, it was very hard to achieve with BricsCAD, because with AnyPath, you could animate only one parameter at a time, so you had to create a lot of dependencies from this parameter. Now, you can simply add several sequences for one parameter, and that's all. No PhD required. Okay, so now our door is closing, and our elevator is ready to go up. And to do that, we will add yet another parameter and set up corresponding duration. Maybe 15 seconds will be enough for this elevator to go up. As I said, it's a heavy elevator, it takes time. Okay, so now Ilya just fill in proper values. Okay. Okay, our elevator is on the right floor. And all we have to do now is open the door. And again, we add another parameter for this door opening. We are ready to render our video, and we have a special button for you. How convenient. And in this dialog, you can adjust the frame rate, the screen resolution, the required format. We support AV, MPG, and VWV. And also, you can adjust the start and end time for this rendering for a case that you don't want to render the entire animation. And of course, BricsCAD uses our rendering engine, so it may take time to render this video. We respect your time, so we'll not do it. We will show you just the final result. And it will be like this. Okay, thank you for your attention. And now I will pass my word back to Dmitry.
Okay, I was asked to finish this session 10 minutes before schedule, so I'll take not more than 5 minutes of your attention. I'd like to briefly summarize. We did not include all these features in our demo because some of them looks quite trivial, but it's important to mention. For example, speaking about parametric modeling, we did not show that constraints now can be put on vertices. So you can put constraint on faces, on edges, and on vertices as well. And yes, there are geometry-driven constraints. There is 3D path constraint, the possibility to parametrically suppress entities, and something more. We updated a parameters panel, and we call it now parameters and constraints. Because now it displays also non-parametric constraint, and now it's a single source of all constraints in your model. So if you are not a mechanical user, then you can avoid using mechanical browser and use only this panel to control parametric behavior of your model. For drawing use, I want to make a step back and inform you that none of these features we list and we present you are included in the latest beta. Some of them will appear only in release and maybe even slightly later, because they are still under development. For example, fast generation of draft quality during use is still under intensive development, but already gives promising result. That's why we mention it. It will really allow you to speed up, to put your views on layout. We already mentioned and demonstrated to you standard representation of threads. But we did not show you the support of AutoCAD mechanical symbols. Now this support is built in BricsCAD, and if you have a file created with AutoCAD mechanical, with welding symbols, with power dimensions, with anything which is possible to create there, they will be correctly, such files are correctly rendered in BricsCAD. And of course the next step is to be able to create these symbols in BricsCAD. And we also show you unfolded view integrated with our standard drawing views. A lot of new features in assembly design, and Maxim presented you all. I will not mention to save your time. The same for sheet metal, hems, tabs and slot, curved junctions between lofted band, propagate, and the possibility to create edge flanges from 2D contour. Something we did not mention before, but it's also very important when you work in mechanical design environment. You, of course, want to import and export your assemblies and parts. And for that, we have import and export command in BricsCAD. Some of these formats require communicator license. Some of them are built-in, so you can use them with just BricsCAD license. And in V20, we supported new file formats, as you already saw. We support Rhino import. We also support Rhino for export, by the way. And this does not require communicator to use. With communicator, you can import now a couple of new formats, such as compressed step and assembly SAT. And of course, we updated some native formats supported with communicator, like Inventor 2020, Creo 6, and so on. And 3D animation framework is something new, still not available in beta version, but we plan to release it. Allows you to create spectacular animation. Maxim demonstrated this panel to you on a simple example, but this morning you saw a much more spectacular example, and so everything is possible, everything is in your hands. Please try to use it and share your experience with us. And in the end, I just want to give credits to my colleagues who develop all this wonderful stuff. And of course to Ilya, who was brave enough to demonstrate all this in live. So, thank you for your attention, and it seems that we have to go downstairs now.